We are the first company, and this is the first material, that has all the properties needed to rapidly, specifically, and economically pull toxic metals out of water. When we first created the polymer, the day that we were able to isolate it in the flask, we were all very excited. And then as the days went on and we kept challenging this compound, it kept meeting the requirements time and time again, and the challenges, and it kept rising to the occasion every time. We got more and more and more excited. So it wasn't really until the end that we really sat around and said, this is something that has never been made before. And we sat back and said, we really have something here that could address some of the major issues, environmental issues the world has, and solve some real pressing challenges that we currently have. There are many different parts of this discovery. The first are the compounds that can actually pull the metals out of the water. So if we look at that first, what we'll find is that we're able to economically and rapidly pull toxic metals out of drinking water. One of the toxic metals that we bind is actually lead. So we have solutions to the lead contamination that's in the drinking water systems around this country, and in fact around the world. The polymer is a non-toxic material. By that, you're able to decompose it. It is not absorbed, it does not accumulate in you. It simply is something that is totally inert and is something that you can touch, you can be exposed to, and it doesn't have any toxic characteristics. And that was an important attribute for this polymer. Another major use of these polymers are to assist in the mining of materials. So, for example, we have looked at rare earth metals. And rare earth metals are used in many, many products. The problem is that all the rare earth elements are currently produced in China. The US does not have a domestic source. We've looked at isolating these rare earth materials, or these rare earth metals, from phosphate waste products. We're able to economically and actually selectively pull out the rare earth elements from this waste material in yields equivalent to that the mining companies are able to extract it out of the rare earth ore. And what that means is that we are able to meet at least 50% of the US demand for rare earth metals using our technology. The potential impact for jobs within the state of Florida is in fact profound. It's estimated that it represents about a $1 to $1.5 billion industry. When you look at the impact of that mining on the manufacturing sector as a whole, when we're able to bring the raw materials into the United States and to provide a source for those within the US, then companies will locate their manufacturing facilities next to the raw materials. So we'll be able to have the manufacturing for things such as cell phones, television sets, the various kind of munitions, GPS systems, the turbines for wind power, hybrid batteries for automobiles. Those are all things that are not made here because the raw materials aren't here. By bringing those industries back to the United States, we're able to have an impact that far exceeds that of simply mining the metals. You're looking at an impact that's 100 to 1,000-fold that of simply the mining industry. So there'll be expansion, not just with our company, but with every single company that will license our technology or that will use our technology or will use our products. Initially, we were creating a polymer that could bind toxic metals. And when we were successful doing that, and we kept looking at the various challenges, we realized that the polymer-metal combination also offered a whole host of novel molecules. Because if you've Imagine that you're taking a metal and binding it to a plastic. Well, no one has ever done that. So we're able to take a metal and bind it to a plastic material. But now that plastic metal complex has its own properties that we then set about discovering. So that's another wave of novel innovations that we're going to be developing over the next 2 to 3 years. Just imagine, no one has ever created a plastic that binds metal, and no one has created a plastic that has incorporated metal into it chemically. So now we can take the best of the plastic and the best of the metal. We can have potentially lightweight batteries. We could have wires that are plastic wires that could actually transmit electricity and signals. We could revolutionize circuit board development in terms of flexible circuit boards. We can produce catalytic materials with these metal polymer complexes, since they bind copper, and copper tends to fight off infections. We could make sutures that have the copper embedded into it. There's a whole host of different impacts that will result from these compounds that, again, have never been created before. So every day we're discovering new things that we can do with these compounds. And so we're constantly writing patent applications and bringing those materials forth and commercializing them. I think this will provide an opportunity for materials to be made, for products to be made, for industries to do what industries do, and that's create things and improve the standard of living of everyone without having the environmental impact that we tend to just accept. And we're also able to maybe do things that we couldn't do before. By creating a lightweight battery, we may be able to travel to planets that we can't even dream of now. So I will leave it for the scientists, both now and in the future, to look at what we have and to dream of things that they can do by using these polymers.